This is part 6 in a series of videos in which I'm attempting to repair and boot this MIMI 802 computer from floppy disk. I'm also repairing a second machine that has the same issue. I've got them both up to the point where they will read the first sector from floppy disk, but neither machine will boot from those disks. So in the previous videos I've gone through the basic code that seems to be running and looked at the ROM, seen how the ROM reads the first sector, and come to the conclusion that the disks that we have are not boot disks for these two machines. But of course there are so many things that can complicate issues like this. If you're familiar with doing this sort of thing, then you'll know that there are many things that you can miss and lots of small details that can trip you up. So what I tend to do when I come to a situation like this, where I've come to a conclusion that something that seems like it should obviously work, such as the boot disks, don't actually work, then I'll sort of backtrack a little bit and see if I've missed something. And that's what this video is all about. It'll be a fairly short video. It's not going to make much progress with the underlying cause, but I just wanted to demonstrate a technique you can use to really consolidate the work that we've done to this point and really try to establish where the issue might be and if the problem is in fact with the incompatibility of the disks. Now, the first thing is we've seen that the machine can read the first sector of the disk, so the possibility is that the formatting of the disk is incorrect and we're reading the wrong sector. But having scanned the disks, there are 4 bytes that the ROM code looks at when it first loads the sector to see if it's the right disk, and those tests are failing. The first 4 bytes on the disk don't match what the ROM is looking for. So it could be that the machine those disks were for is a different version and has a different ROM. Perfectly possible, and that's kind of what I'm trying to establish here. So the way I've decided to go about this is just to really try to prove whether this machine can actually load a sector from floppy disk and then hand control to the code that it's read. And because obviously the proper disk won't work, what I've done is I've written a mini operating system. So this is the code for it. It's fairly straightforward. This is Z80 code if you're not familiar with the MIMI. There's not a great deal. There's 512 bytes because that's what fits in a sector on the floppy disk. But what this does is very straightforward. It just configures the hardware on the MIMI so that we can write to the screen. Of course, when you've got a machine like this with no operating system running, and bearing in mind that the ROM does not have any inherent ability to write to the screen, you have to write everything yourself. So what I wanted to do was write something I could put onto the floppy disk that would be loaded from floppy disk at the boot point where it would normally load CPM, and then would hand control to that code, and then that code would do something that we could properly establish it was running. So that's what this code does. All it does is it writes a string, it initializes the machine and then writes a string to the screen. Now, one of the problems I had with this, if you recall from previous videos, is that the bootstrap in the ROM only copies 80 hex bytes from the first sector that's read into the RAM location it then hands control to. And I couldn't find a way to write system code that would send data to the screen, initialize the machine, and have space for the strings that would fit into 80 hex bytes. So what I've done is I've made a very slight modification to the ROM code. So the ROM I got fitted is not the original one. It's identical apart from, if you recall this code, this is the ROM code, and this part of it is where it copies the first 80 hex bytes of data from the sector it's read from the floppy disk to essentially low RAM, beginning of RAM, and then it hands control to the beginning of RAM, and that's what starts the second stage bootloader. So what I've done is I've just modified this, so instead of copying 80 hex bytes, it copies 200 hex bytes. In other words, it copies the entire 512 byte sector, into RAM starting at address 0, and then the bootstrap just hands control to address 0 once it's done that. And that means that I can have a 512 byte block of code for my operating system. Okay, so that's what I've done. I've modified the ROM, I've got that fitted. To save time, I have tried this with a floppy disk, but to save time and so I don't have to keep rewriting floppy disks, I'm using the emulator here, and this also is to prove the emulator actually works. So what I'll do now is I've got the code I've produced for the boot sector on the floppy disk installed into the emulator. In fact, the entire disk image is in the emulator. And what happens now is if I boot the machine, it should read the first sector from that disk, load it into lower RAM, hand control to that, and then my mini operating system should start running. So what I'll do is I'll point the camera at the screen and we'll see if it actually works. Okay, so we're looking at the monitor screen. I'll now boot up the Mimi, and what should happen is it should start up the monitor program. It should then load the first sector from the floppy drive emulator, and it should then start running the code that it's downloaded from the emulator. So I'll boot it up now, and as you can see, it's actually working. I'll reset the Mimi a few times and you can see the sequence. The British Micro Mimi 802 boot monitor 2.0, that text is written to the screen from the bootstrap loader, and the Jerry was here message comes from the code that was downloaded from the floppy drive. So you should see them appear separately. So I'll reset it now, and as you can see, that's exactly what happens. I'll do it a few more times, and you can see it's successfully and reliably downloading the operating system from the floppy disk. Obviously very advanced operating system, I'm sure there'll be a huge demand for it, but it is proof of concept. It's proving that the system can successfully read code from the floppy drive, it can copy it successfully, and it can hand control to it and successfully run. It may seem fairly trivial, but it proves that the system runs, it proves that the hardware is working the way it should, and it proves that it can successfully and reliably read from the floppy disk. Also, the code needs to do quite a few other things rather than just put text on the screen. There's no inherent capability within the boot ROM on this machine to write text to the screen, or to configure the hardware for that matter. That all has to be done within the operating system that is putting up the message I've put on the screen here. So it's a huge step forward in terms of proving that the machine is running. Unfortunately, it does tend to confirm that the disks we have are not boot disks. If anyone out there has a boot disk from Mimi, then please let me know. All I really need is the image from them, and that would get both of these machines up and running. Failing that, the only way forward I can see with these machines is to write a version of CPM specifically for the two machines I have here. It's not something I'd really want to do, it's very time consuming and tedious, but it's possibly the only way we're going to resurrect these two machines.